to quantum convergence. So today in this video, we are going to learn about phonon calculation, how we are going to perform a phonon calculation using CASTEP tool in the Metal Studio, and what are the uses of phonon calculation and phonon dispersion curve, and what are the various methods to do the phonon calculation. Okay, so let's get started. Actually, phonon calculation, see, if you have seen my videos on the molecular models and the molecular calculation using Gaussian, you might have seen the frequency calculation and the geometry optimization. So in molecules, we use atomic basis to do the geometry optimization and the frequency calculation. So the frequency calculation is the second order derivative, which will tell you about the minima of your molecule on the potential energy surface. If there is a negative frequency, means your system is not minima, it's local minima, or there is a negative frequency, means your system is not a minima on the potential surface. So what you do, you follow the negative frequency and find out the minima. Similar ways on materials in the CASTEP, what we do phonon calculation, and for the materials to confirm whether this material is a minimum of the potential surface, or it is a dynamic stable molecule material or not. So phonon calculation will tell you about the dynamic stability of your molecule. If you want to do the thermodynamic stability studies, you have to perform the dynamics. That is, you have to perform the quantum dynamic studies that will tell you about the thermodynamic stability of your system. To find out the dynamic stability of your system, you need to perform the phonon calculation. So what you need to do is, phonon calculation, there are right now in Metal Studio, there are two methods to perform the phonon calculation. One is the displacement method, and another is the linear response method. Displacement method uses uses the supercell to do the calculation in just in the supercell. So that method is not that accurate as a linear response method. So the linear response method is the best method for the phonon calculation. And we should follow linear response method that will do calculation on a periodic system, and that will give you more accurate results. So suppose this you're having any structure. Suppose this is your structure that you want to perform for your calculation, and this is the two-dimensional sheet right now, and you want to perform a phonon calculation. So phonon calculation will use, there are slightly different things here. Whatever things you have used in CASTEP calculation here will be same. So if your system is having a weak interaction, you can use a Grimmé correction or TS correction, whatever you want to use. You can use Grimmé is better than TS, and you can choose a functional and the quality here, and you have to choose geometry optimization here. In the mode menu, you select optimize cell and keep everything as it is. In the electronic, you have to use non-conserving pseudo-potential. Okay, either use non-conserving or OTFG non-conserving. You can restrict yourself to non-conserving, and OTFG non-conserving, both are okay. OTFG is slightly better than this one. So you have to use non-conserving pseudo-potential here, and the relativistic treatment you can use default one, no problem. And whatever energy cutoff you want to use, you can use it here. Suppose you want to use 800, 500. So I will suggest 5 to 600 is okay. Will give you the good result. No need to change anything. In the K point section, you can go to the separation. Either you can choose the fine quality, or in the separation, for the better results, you can go with 0.04 1 by angstrom. Okay. That will give you the more accurate. But suppose your system is bigger, phonon calculation is a very costly calculation. It will take more time and more space of your system will take. So if you want to use for better calculation, okay, so you can put 0.04 angstrom here, or else you can use this fine with this cutoff separation. In the properties, you can select band structure and density of state. If you are interested using this non-conserving pseudo-potential. Otherwise, right now I am interested in the Phonon dispersion, and we also go for polarability and IR calculation, so that you can show this how the negative frequencies are moving here and there. In the phonon calculation, click on both means density of state and the dispersion both will be calculated. If you want to calculate for longitudinal optics and the transverse optics, you can click here. For LOT or splitting, both will be calculated, and use linear response method. You can also use finite displacement, but I will suggest to use linear response method, which gives better results. Select the linear response method and go to the more, and here you need to select the K-point path. You give the K-point mesh here. I have already taught you how to do this, how to give this K-point mesh. If you don't know how to do this, just watch my earlier videos in how to do the band structure calculation. There I have shown how to select this below zone. Okay, you can click here on the reset or the create. It will give you the below zone. I have mentioned there how to do it. This is slightly tricky. Okay, once you have selected job control, you can tick everything, put your processor and run the calculation. Okay, that's all you need to do. It will take at least, depending on your units and elements, 6, 7 days, 8 days, 10 days, 20 days, month, years it can take, depending on your system. Okay, once this calculation is over, click on the output structure, go to the CASTEP calculation tool, go to the analysis, and here you need to select the Phonon dispersion. Okay, and energy unit you can take in the terahertz, or you can excuse me, you can take in the centimeter numbers, whatever you wish. I will take this as terahertz view. Okay, and you'll see one dispersion curve here on your screen. Okay, we are interested at this at 0 level. You can see every time, see there are two types of bands in dispersion. One will be acoustic, another will be optical. So this is known as the acoustic band, and these are the optical bands. Okay, when these optical bands is crossing this 0 level energy and going down, going below 0 frequency, that will gives you instability in your system, and that's how you'll be getting negative frequency. In this case, we don't see any optical band crossing the 0 level. This you can see this slightly negative here, but this is not a negative actually. These are the these are the acoustic bands. Okay, an acoustic band will be triply degenerated gamma. Okay, and you can see this is a triply degenerated and slightly coming negative, maybe some a theoretical inaccuracy or an artifact. This doesn't mean instability in your system. This is just because of this theory or a computational error or something. Okay, so if there is a non-active frequency, it means your system is totally perfect. You can use it for the calculation mentioning. If at all there is a negative frequency, you have to follow that. Okay, I will tell you how to do those things. So this is your output, right? If you want to see those frequencies, now go to the IR spectrum. In this case, you can import. Once you have imported, now go to the tools. In the tool menu, you can go the vibration analysis. Now calculate. Now these are the various frequencies. Suppose if there is a negative frequency in your system, you can see that negative frequency, and you just click on the negative frequency and animate. Here we don't have negative frequency. I'm just telling in case you have negative frequency. Okay, right now we don't have any negative frequency. I'm just animating this 186 centimeter inverse frequency, and here you can see this frequency is talking about the oxygen going here and there. Okay, so similarly, if there is a negative frequency, in that case you need to do this animation, and you need to pause this movement here using this, and manually you need to change this where there is a equilibrium, and then you need to copy that geometry, and further calculation has to be done on that. Okay, that is the way to track your negative frequency system. But in this case there is a non-active frequency, so it's okay, we can use it. So you can save this animation as it is. Like if you want to save this animation as a movie, you can do that also. Go to the file menu, go to export, and you can save this as a animation to zip file. Whatever way you want to move, you can do. That depends on your way of doing. Okay, so this is the way to do the frequency Phonon calculation and analysis in the CASTEP tool. If you have any doubt, you can put in the comment section. And if you want to collaborate with me, or you want to put me as an author in your publication, you can do that. Just you can send me an email. I will have given my email in the description now. Just check into my email. Just send me an email saying that you want, like, whatever information videos I'm sharing that is very informative, and you want to uh, you know acknowledge me in a paper as an author. And if you want me to do some uh, review thing or some analysis, just put in your email, and just we'll have a look into it, and we'll just work it out. Okay, thank you for watching the videos. Don't forget to share